Welcome to chapter 23. Today we're going to start talking about fabrication and fitting. We're going to talk about some of the terminology, some of the best practices, and this is, even in 2 years we can't turn you into a fabricator. What we can do is give you the tools you need and the thought process you need to learn to be a fabricator once you get out in the real world. There's just too much to learn. I didn't consider myself to be a good fabricator until I've been welding about 8 or 10 years. At that point I was pretty good. The guys who've been working at the job 30 years and trying to learn every day, they were real good fabricators. And that's the thing about fabrication, is you're never done learning. You're always picking up tricks. The guys that are really good at it, have been doing it for 30 years, every day they're still trying to find tricks. So that's really the whole key to being a fitter or fabricator, is trying to be better every day. So in 2 years we can't make you a fabricator, but we can get you ready to become a fabricator. So anytime you're planning a fabrication project, from something little to something big, the first thing you think about is safety. If you start thinking about safety at the point where you're planning the project, it makes it a lot easier to incorporate it when you're actually doing the work. And what that looks like to me is, how am I going to build this thing safely? Am I going to need to be up on a ladder while I'm building it? Is my table the right height so I'm not stooped over, hurting my back, or I'm not, reaching up high, in some non-ergonomic position? And how heavy it's going to be. We can all build something in our garage or our shop that's so heavy that we can't move it. We need to start thinking about that before we actually put it together. You wouldn't believe it, but I worked the shop I ran at Motive Power. We had 50 ton of hoist in the main bay of our fab shop. We had the engineers design a locomotive frame that we couldn't lift. And luckily, we let them know that we only had 50 ton. They thought we had 60 ton. So we totally could have built a frame that we would have been unable to get out of our shop if people hadn't been paying attention. So again, that's stuff to think about. Will your forklift lift it? Do you have enough forklift capacity to lift it safely? So think about that stuff all up front. Think about the materials. You're welding stainless steel with stick, you're going to have to worry about hexavalent chromium. You're welding galvanized stick, you're going to have to worry about the fume that it produces. So again, think about all that stuff up front. It'll be way easier to incorporate when you actually build it. Now there's a lot of terms of fabrication we're going to talk about, but the big one is for me, it's kerf. What is kerf? Well, kerf is the material that's removed usually through a thermal cutting process when you make a cut. An example of that is torching or plasing. When you make a torch cut or a plas cut, a section of that steel is removed. Some processes don't produce a kerf. Shears don't produce a kerf, they act like scissors. If you take a piece of paper and cut it with a piece of scissors, it didn't remove any material, it just made one piece into two pieces. If you stuck them back together, it'd be the exact same length. Shears, we can do that with. Saws, torches, everything gets shorter when we cut it, because we're taking on a saw, we're taking the blade width out every time we make a cut. On a torch, we're taking the cutting stream width every time we take a cut. And why that's important is you have to know that when you're laying parts out. So an example of that, if you're in the lab, we cut coupons all the time. So we've got our strip we're going to cut coupons out of. They're 1.5 inch coupons. We do this through our iron worker, so we don't have a problem. We can lay them all out at once, chop them all up at once, and they all come out the right length. If I had to cut these with a torch or plasma, I couldn't do them all at once, because every time I make a cut, my piece is going to get shorter. So I've got to lay one out, cut it, lay one out, cut it, lay one out, cut it. So not a terrible thing or anything like that, but it's something you've got to realize. I've seen lots of people at the saw and they want to cut 10 pieces out of a stick of pipe or a stick of tubing. Well, they lay them all out and cut them all, and then every piece is shorter than the last, and ends up, the width of a saw blade is 1/16 of an inch about. You make 8 cuts, it's 1/2 inch. So think about that. That's why I like shears, the iron worker, because it makes it easy. We don't have to think about the curve. So one of the biggest features or things you're going to have to deal with when you're fitting stuff up is tacking stuff up. In the welding lab, you're tacking stuff up all day long. You're tacking the coupons together. But tack welds are real important. We get real lackadaisical about them, but they're actually really, really important. Not just for building, but for safety. We don't want parts falling off of something while we're crawling around welding it out. We don't want parts falling off of when we pick it up with the overhead crane. We don't want to pick it up with the overhead crane and have the pieces that we're lifting it from fall off. Tack welds are important, and with tack welds, one size does not fit all. It all depends on the material, just like welding does. If I'm welding on thick material, 1 or 2 inch plate, I've got to preheat before I tack, because otherwise those tacks are going to fracture because they're quenching themselves in that giant heat sink of plate. So thinner stuff, it's not that big a deal. But if I want something to stick together while I'm welding it out or while I'm transporting it, I'm going to put more than just these little button tacks. I'm going to put 1 inch of weld in there. That's going to be my tack. And if it's thick material, I'm going to preheat before I tack too. One of the things with tacking is you can get into a lot of trouble, make your life really, really difficult by not tacking where you should tack. And what I mean by that is my guideline is I never put a tack somewhere where I can't get a grinder. Because just invariably, you're going to tack something in someplace you can't get a grinder, and you're going to move that part. And it's going to be the best tack you've ever put on in your life. That's just the way the world works. The tacks that you really want to hold, they'll crack. The tacks that you wish would just fall apart, they're there forever. They're like X-ray quality tacks. So think about how big your grinder is, because that's going to dictate where to tack. I really like big grinders. I like 6 inch wheels because I can usually get a little more reach out of them. I'm going to draw a big piece of angle iron. So this is a piece of angle iron. Let's say this is 5 inch leg, both sides. So when I'm tacking this, as long as it's out in the open where I can pretty much get all the way around it, this side right here and this side right here, totally okay to tack on because I can get a grinder to all that. These corners, they're totally okay to tack on. I can get a grinder to those. I can even get, if I've got a 6 inch grinder, I can probably get in here and put a tack in. But this right here, that is no tack land. You'd be amazed how hard it is to break a piece of angle iron off if you put a tack in this corner. And I'm not saying I don't do that, I do. I do it all the time. But tacking in a corner is a political statement, okay? You're saying, this part is where it goes and I don't care if I'm not moving it. That's what tacking in a corner means. And sometimes you do that. Don't do that, okay? You'll be much happier when you think, oh man, the print changed, I've got to move this part. Well, I just grab my grinder and cut it out, not having to grab the air arc or a torch to cut off one tack on a piece of angle iron. Let's talk about, let's talk about some of these layout methods that we're going to use. And there's a ton of them. I use them all from at one time or another, but I've got some favorites. So as far as putting lines down, that's the basis of laying stuff out and fabricating, is being able to draw lines on steel. I like silver pencils. I like soapstones. I like scribes. Some industries you can't use scribes because it'll mar the surface finish, but I really like scribes. And along with all those, a lot of times I like center punches. If I'm going to lay out a reference line on a part that I'm going to come back to many times, that I don't want it to rub off, I might come back to it a year later and have to pull measurements off of. In the rail industry, they do that all the time. I will center punch mark over my line. So in our world, where we built locomotives, the key feature of a locomotive were these center lines of the bolsters. And the bolsters were where the truck's attached. So I'm going to draw a really terrible drawing of a locomotive, but that's terrible. That's better. Here's your window. Here's your cattle catcher. So the trucks are down here. They've got the wheelies, technical term. What they mount to is a center pin. And where those center pins are the reference points of that locomotive. Every dimension on a locomotive when you're building the underframe comes off those points. They come off those bolsters. So when we're building this, we just got the frame stripped down. I'll draw kind of a top view looking down at the frame. Got our 2 frame beams. and we've got our bolster assembly. And it acts like a cross member in between the frames. And on this bolster is the giant center pin that we use. So this center line, or this pin, is our reference point. So what we'll do is, when they actually build this bolster offline, they will lay the center line out on this piece, and they will center punch mark all across that part about every 4 inches. And a big heavy center punch mark that you can feel with your hands. You can see even over after 2 or 3 layers of paint is on it, you can still see that center punch line. And then when we install the bolsters, we would continue that line out across the frame beams and even across the extenders that came out to the side sill. So we always have a reference. We can always go find that center line real easily. And it comes in real handy because locomotives get wrecked all the time. And when you're doing repair work, all you have to do is climb under that thing and locate that center punch line mark where you can find it because it's center punched, and you've got a reference point to rebuild something. So, like I said, a lot of times if I care and it's something I want a reliable center that I'm going to use for a while, I'll just run center punches on it. The other key thing to lay out when we're drawing lines is when we're drawing lines, especially where parts go or where we're going to make a cut, we want to identify where that part goes or what side of that line we're going to cut on. I've seen tons of people lay out lines in exactly the right spot and then put the part on the wrong side of that line.